In this video, we're going to try to find upper bounds for an integral. Let's consider the following function. F of x is 1 over 1 plus x to the power 4. And when we integrate f of x dx between 1 and 2, we have to prove that it's bigger than 1 over 17 and less than 7 over 24. The question is, how can we do that? The first thing that we need to notice is that our function f of x is bigger than 0 for all x's in R. Okay? Because it's a reciprocal of a 1 plus a square. Therefore, it's always positive. In fact, it's never 0. And the aim here is we want to find, let me graph it a bit here. Let's assume that it looks like this, okay? And we want to graph it here and see that it's between 1 and 2. This is the area. We want to prove that that this area is trapped between 1 over 17 and 7 over 24. The key here is that we see that this function is decreasing. Okay, between 1 and 2, we have our function is between this value here, between f of 1 and f of 2. And therefore, since it's decreasing, we can find the minimum. The minimum that we denote m is the value of f of x between 1 and 2. And we see that clearly, we see that it's f of 1. F of 2, sorry. Okay, f of 2, because it's decreasing. And we need to prove this one, but we are not going to do it. We need to do that. We need to show that f is the minimum. But for us, clearly, f is continuous and decreasing. We can accept that this is the minimum. And the maximum is defined as f of 1 for x between 1 and 2. We can find that the f of 1 is just 1 over 2. And f of 2 is 1 over 1 plus 2 to the power 4. It's 1 over 1 plus 6. It's 1 over 17. Okay? And clearly we see if we use this, what we know about the order in for integrals, that if f is between a minimum and a maximum, then its integral, the integral of f of x between a and b is b minus a times m and big M times b minus a. Okay, let's see if we can get something from this result. If we get the minimum here, we see that b minus a is just 1. Okay, so therefore the integral between a and b for the minimum, it's 1 over 17 times 1. Therefore, we get our first result. For the second result, the maximum is 1/2. But we don't get this result here. We don't get 1/2 here. It's true. Okay? It's true here. But we can do something better. Okay? We can do something better. In fact, to get this result here, okay, we need to notice that 1 over 1 plus x4 is less than 1 over x4. Okay, this means that we are approximating f by some function that's almost the same, but it's always bigger than that. So 1 over x4 is bigger than 1 over 1 plus x power 4. Okay, therefore this integral is going to be bigger, but it's very close. This means that we can integrate here. So this is 1/2, but if we do this ordering, that 1 over 1 plus x to the power 4 is less than 1 1 over x to the power 4, and we integrate between 1 and 2, Here we see that we get 7 over 24. This integral, if you do evaluate this one, you will get 7 over 24. Okay, and this is a better approximation because this is 0.7 and this one is 0.5, and therefore our integral now f of x between 1 and 2 is between 7 over 24 and 1 over 17. Okay, the key that we used is that if f is less than g, then the integral, we will have the same order. F is less than g, the integral between a and b of f is less than the integral of g between a and b. This is the fact that we use here using this function here. This is our g, this is our f, and a and b are 1 and 2. Okay, so this is one way to prove this result. To get this one exactly is to use this technique here. Okay, I hope this helps. Thank you very much.